Okay, I think this will be a pretty quick video over limits that involve infinity. Okay. And there are lots of problems that can take the form that this one takes, but this is the simplest one. And I think if I show you this one, then you can see the same thing happening in lots of other problems that at least appear different. Okay, so if we understand this, we're off to a good start with this topic. So first of all, this says, what is the limit as x goes to 0 from the right? That plus right there means from the right, okay? For the function y is equal to 1 over x. So how about, since we haven't seen this kind of limit where it says x goes to 0 or x goes to somewhere from just the right, I want to make a table, all right? Just so that we're clear what x goes to 0 from the right means. So here's my table, and you've seen me make tables before in order to figure out limits, but here's my table, and I'll show you what x goes to 0 from the right. Now, from the right means like from the right of 0 on the number line. You know, on the number line, there's 0 in the middle, then there's the positive numbers to the right, and then there's the negative numbers to the left. So x going to 0 from the right might look something like this. Let's say 0.5. That's definitely right of 0. Let's go a little bit closer to 0. 0.1. And then 0.01. And 0.001. That's what I mean. You know, this or something like this is what we mean x is going to 0 from the right. All these numbers are right of 0 on the number line. Okay, now we can argue about why these numbers, why not 0.6, why not 0.2, why not 0.013. That doesn't really matter. There's a pattern over here that the closer the x is to 0 from the right, then the y will do something. Like even if you choose numbers slightly different than me. Well, let's see what that is. So if I put in 0.5 for x, I'll get 2 for y. If I put in 0.1, I'll get 10. If I put in 0.01, I'll get 100 for y. If I put in 0.001, I'll get 1,000. And is there a pattern, right? That's what we're looking for. A pattern. We want to say if x goes one place from one direction, y goes some other place. Well, the pattern I see looks like the y's are getting bigger and bigger. And if you extrapolate from that pattern, it seems like the smaller the x is, the smaller and closer to 0 x is, the larger the y will be. Okay? And that's just a truth about arithmetic. In arithmetic, when you divide, the smaller number you divide by, the bigger answer you get. Okay? And there's no ceiling to this. The smaller this is, the smaller and closer to 0 this is, the larger that will be. How large can it get? Well, there's no ceiling to how large it can get. The y will go to infinity. Okay. So, either by table or concept, I want you to be able to see that. All right? The table is the table. The table is the pattern. It suggests that y goes to infinity. The concept is that the smaller number I divide by, the smaller and closer my number is I divide by, the larger my answer is that I get. Okay, so I don't know. I mean, we've drawn tables and so on before, and we've also made graphs. So I thought, well, maybe it might be consistent if I did a graph. So why not? So here's my graph. What does that graph look like? You've seen graphs like this before, but here's y equals 1 over x. Okay, that's what it appears like. And I see that if I were to follow the points around, like the points as the x gets closer to 0, the y has to climb higher and higher up on that graph. I mean, this is just what the graph of that looks like. If you weren't familiar with that graph, then we'd have to learn to draw that and so on. But if I follow like this point, over to this point, over to this point, over to this point, as the x goes to 0, right, 0 from the right, then the y will go to infinity just by following them. Okay? Another name for that, or another way to say it, is that this graph, as it kind of forms itself to the y-axis, it goes closer to the y-axis but never touches it. That's called a vertical asymptote. Maybe you've heard of that before. Vertical asymptotes on graphs will normally mean limits to infinity or negative infinity at that point. Okay. All right, now let's see an example to compare with that one. What about if x goes to 0 from the left? Same thing, y is equal to 1 over x. Well, I think that will change the signs, the pluses and minuses, but I don't think it'll change the concept about dividing by small numbers real close to 0 and getting big answers. So I still think this one's going to involve infinity, but nonetheless, what does x goes to 0 from the left look like? That could look like negative 0.5. That's left of 0 on the number line, and we want to go towards 0, so negative 0.1 would be a tad closer, negative 0.01, negative 0.001, something like that. Here's what x going to 0 from the left is going to look like. My y values, negative 2, okay, negative 10, negative 100, negative 1,000. It's still true that the smaller and closer my number is that I divide by, the bigger my answer is. But of course, if you take a positive, divide by a negative, you get a negative answer. So, well, okay, where are the y's going? To negative infinity this time. Okay, negative infinity. So this limit is negative infinity. All right. Do you see the patterns suggesting our answers for the limits? Now I drew a graph for this one. Might as well do this one. I mean, it would be the same function. Y is 1 over x. I didn't draw all of it over here. If there's another portion to this graph, over here like so, okay? And if I follow the same points, let's see, where would the points track if you had their x coordinates go to 0 from the left? That would be like this point compared to this one, compared to this one, compared to this one. And as this graph goes down, it never touches or crosses the y-axis. There's still a vertical asymptote there. But sure, like right in here, if x goes to 0 from the left, the y's are going to go down to negative infinity. Okay? You can see that on the picture. You can see it on the table. All right. Now, so say we get the concept down there. Let's look at some that might appear to be different. Okay? I think this one appears to be different, but let's see. Here, I would see, I guess I could do this in two ways. If I understand those first two problems that I just showed you on the other side of the paper. Here, if x goes to 0 from the left, those numbers down there will be very small. If I take like a very small number and I raise it to the third power, it will be even smaller. And it will be negative, because if x goes to 0 from the left, those are going to be very small negative numbers. Okay? So let's give like two methods for this. Here's my first method. Okay, now this first method does rely on the fact that you have some intuition and instinct about numbers, but it goes like, and it's like those first two examples, but it goes like this. The form this is going to take is negative 7 over a very small negative number. If I made a table, that's what it would look like. Okay? And so a negative divided by a negative is positive, but 7 divided by a very small number, and by very small I mean like kind of like what was happening over here. Take this as far as you want, make those as small as you want. It's going to, like, just in rough terms, rough description, going to be a very big positive number. Okay? So I'm saying that that suggests that in the table we would get an infinity. All right. There's my answer. So you might have the instinct for this right away. That might be something you have to warm up to a little bit. But I can help you warm up to this by maybe making a table right along with it. It's still okay to make a table. Okay, so let's go ahead and make the table. That way you can see these numbers. Okay, so what x going to 0 from the left? That might be like negative 0.5, negative 0.1, negative 0.01. That's x going to 0 from the left. And let me get my calculator, and we'll get the y's, but I think we know, like, I'm just suggesting this over here is going to give it all away. But if you want to do the calculations and see the numbers, there's nothing wrong with that. So let me get my calculator. And then we'll do the math. All right, so I get my calculator here off screen, and I'm doing negative 7 divided by negative 0.5 to the third power. Okay,